In this video, we are going to discuss types of physical quantities. So, let us write first physical quantities. So these are categorized in two parts. First one is fundamental physical quantities and second one is derived physical quantities. This is also known as base physical quantities or base quantities. And the second one is derived physical quantities. Okay, now the units associated with fundamental physical quantities are called fundamental units or base units, and the units associated with derived physical quantities are called derived units. So let us write this. The units associated with the fundamental physical quantities are called fundamental units. Or base units. Here the units associated with the derived physical quantities are called derived units. So now we are going to write some examples of fundamental physical quantities. Length, mass, time, etc. And here the examples are force, density, pressure, etc. Now the units associated with these are base units, and the unit associated with these are derived units. So let us write here the SI units for these base physical quantities. So for this, for length it is meter, for mass it is kilogram, for time it is second, for force the unit is Newton, which is, what can we write it, kg meter per second square. For density we can write kg per meter cube. For pressure, Pascal. And what can we write here? It is thrust per unit area. It means we can write it as kg per meter second square. So these are the units. So here we have written the SI units. Okay. In the next section we are going to discuss the system of units. Now we are going to discuss system of units. Earlier there were different system of units. Earlier there were different systems of units. Okay, 3 of them were, first one, the CGS system, second one is the FPS or British system, third one is the MKS system. Okay, now we are going to see what are the units in these systems for the base quantities length, mass and time. So for length, mass and time, CGS units. So in CGS units, for length the unit is centimeter, for mass the unit is gram, and for time it is second. Okay, so this is centimeter. This is gram, and this is second. Okay, in FPS units, for length it is foot, for mass it is pound, and for time it is second. In MKS units, for length it is meter, for mass it is kilogram, and for time it is second. Okay, at present the system of units which is in use is SI. Okay, which is International System of Units. Okay, in SI there are 7 base units. Okay, there are 7 base units. At first we are going to see SI base quantities and units. So in SI there are 7 base units. So we have 7 base units. So here we have written base quantity and the name of unit associated with it and the symbol for the unit. Okay, for length the unit is meter. In symbolic form we write it as small m. For mass the unit is kilogram. In symbolic form it is kg. For time it is second and the symbolic form is small s. For electric current it is ampere and the symbolic form is capital A. For thermodynamic temperature the name of the unit is Kelvin and its symbolic form is capital K. For amount of substance the name of the unit is mole and the symbol for this is small m ol, mole. For luminous intensity the name of the unit is candela and the symbol used for it is small c d, which is CD. Okay, in the next section we will discuss about the 2 other units. Okay, so the other 2 units are radian and steradian. So the unit radian is for plane angle and the unit steradian is for solid angle. Let us first discuss about radian. The plane angle d theta is defined as the ratio of the arc length ds to the radius r, that is d theta equals to ds upon r or ds by r. The unit for d theta is radian, which In symbolic form we can write it as RAD. Okay, the solid angle d omega is defined as the area intercepted by the sphere, defined as the ratio of the area intercepted by the sphere to the square of the radius. That is, d omega is defined as dA by r square. It is the area intercepted by the sphere, taking O as the origin, and in the denominator it is the square of the radius of the sphere. So it is the ratio of the area intercepted by the sphere to the square of the radius. So its unit is steradian. In symbolic form we can write it as smallest r. Okay, so these are all about radian and steradian. One more thing is that the quantities plane angle and solid angle are dimensionless quantities. Okay, thank you very much for watching this video. We will do more on units and measurement. Thank you.